Hello and welcome. In today's class, we'll be looking at the stack data structure. This topic is also taken from class 12 ISC Computer Science syllabus. So what is a stack? A stack is a linear data structure that follows the LIFO, which means last in, first out principle. The last element added is the first to be removed. So to understand this notion, you can look at this picture, which is a stack of plates. One plate is kept on top of the other. So when the plates are kept like this, the last plate will be the first to be removed. And the same idea is applied by the stack. The element which is inserted last is the first to be removed. What are the applications of a stack? So it can be used in undo mechanism, because each and every action can be placed into the stack, can be inserted into the stack, one on top of the other, so that we can easily access the most recent action that can be undone. Another application is function call management. So when multiple functions are called in a program, each and every function is pushed into the stack, and when these functions complete their execution, they are popped off from the stack. Another example could be balancing symbols, where in a code we can easily match the opening and closing brackets and find out if all the brackets were closed properly or not. So these are the different applications. There are many more applications, but I have only mentioned 3 here. We can also reverse a string using a stack, because you can put each and every characters into the stack one after the other, and then as you pop off all the characters, the last character that was pushed becomes the first one to be popped, and that way, in that order, you can reverse a string. Now, what are the key operations that can be performed on a stack? The first one is the push operation. So push means to insert an element to the top of the stack. Pop means to delete an element from the top of the stack. Peek simply means returning the element currently stored at the top of the stack. And display displays all the elements currently stored in the stack. So peek and display doesn't modify the stack, it just displays. So peek displays the topmost element, whereas display displays all the elements that are there in the stack. So let's try to understand the push operation in detail with an example. So here I have shown a diagram of a stack with size 5. That's why there are 5 indexes, 0 to 4. And currently it is empty. And there is a variable top, which is always going to point to the topmost element. So currently, because we don't have any element in the stack, it is pointing to -1, which indicates that our stack is empty. So whenever top points to -1, it means that the stack is empty. Now let's say you have pushed one element into the stack. You have pushed 25. So what happens is, top firstly increments itself by 1. So top was pointing to -1. It increments itself by 1. So now it points to 0, index 0. We are implementing stack in an array. You have to think of this like an array. So we know that negative indexes doesn't exist in a stack. That's why we are not going to access -1 as an index. We are just modifying the value of top so that it indicates that the stack is empty. When top is -1 means stack is empty. So when you're inserting the first element, top increases by 1 and it becomes 0. and that's where 25 gets stored. So 25 is the topmost element right now. After that, let's say you inserted 18. So once again, the same operation will be applied. Top will increase itself. So from 0 now it becomes 1. So that's why now top is pointing to index 1. And now at this index, 18 is stored. Then 105 is inserted or pushed into the stack. So top firstly points to 2 and then the insertion takes place. Then the push operation is actually done. Then you inserted 45 and then finally you inserted 72, and we can now clearly see that the stack is full completely. Now, while inserting elements into the stack, we have to be careful regarding stack overflow. What is a stack overflow? So it is an attempt to push an element into the stack when the stack is already full. So you can see that the stack is already full. There is no space to insert another element. But if you still attempt to insert an element, let's say 90, that will lead to stack overflow. It's not possible. So it's like an error. And you as a programmer have to be responsible to write code in such a manner that stack overflow never happens. Next is the pop operation. So in pop operation, let's say I execute it for the first time. So we can clearly see 72 is the topmost element, and in a stack we can only delete the topmost element. You cannot directly delete 45 or 105 without deleting 72. So we delete the topmost element 72. So 72 is returned, topmost element is returned, and then later top decreases itself by 1. So after giving out 72, then it moves to index 3. Now 45 is the topmost element. Now when you are deleting 45, 45 is returned and top again decreases by 1. So now top is pointing to index 2. So 105 is the topmost element now. Again, when you are deleting 105, 18 becomes the topmost element. When you delete 18, 25 becomes the topmost element. And when you deleted 25 also, the stack becomes empty. So once again, you can see top has reached its initial state where top is pointing to -1. Now, when you are popping elements out from the stack, when you're deleting elements from the stack, you have to be careful regarding stack underflow. Now, what is stack underflow? It is an attempt to delete an element from the stack when the stack is already empty. So right now you can see there is no element present in the stack. The stack is already empty. If you still try to delete something, which is not possible, it leads to stack underflow. So once again, as a programmer, you should write code keeping stack underflow in mind and write code in such a manner that stack underflow never happens. So that's all we need to know about stack. And let's now see how we can write a Java program to implement stack. So here you can see I have created a Java file called stack.java. Let's begin writing the program to implement stack using arrays. First of all, we start with the import statement. We create the class and let's create the data members. So let's say I want to insert integers in my stack. So I will keep the data type of the array as int. So let's give the array name as S. Let's also create a top variable. And these two variables will be the data members of our stack. Now let's create a constructor for this class. Now in this constructor, we will pass a parameter, the size of the stack. So using size, we will create the array for our stack. So if the size is 5, an array of size 5 will be created. So we can write s equals new int size. And top will be initially -1. Now let's write the code for the push operation. So we have to insert some data into the stack. So we are receiving the data as an argument here for the push function. But we also have to be careful about stack overflow. So I can write that if top plus 1 is equal to s.length, meaning that if I increase top by 1 and if that new value is equal to the length of the array, that means stack is already full and it's not possible to insert another element. So we will print a message stack is full. Else, if that's not the case, that means we can easily insert another element into the stack. So we will write s plus plus top equals data. Why plus plus top? Because first of all, we have to increase the top by 1. Top will initially be -1. So firstly, it becomes 0. And then in that index 0, the data is inserted. So if we write the code this way, we will never experience stack overflow, because if this condition is satisfied, it will simply print the message that stack is already full and it's not possible to insert another element into the stack. So that was the push operation. Now let's write the code for pop operation. Now the return type for the pop function will be int, because we want to know which element was deleted from the stack. So each time you delete an element from the stack, the pop function will return that deleted element so that you can receive it in a variable and you can do whatever you like with that variable or that value. So again, when you are going to delete an element from the stack, it's important that you keep in mind the possibility of stack underflow. Means when the stack is empty, it's not possible to delete an element from the stack. So if top is equal to -1, it indicates that the stack is empty. It's not possible to delete the element from the stack. But at the same time, we have to return something from the stack even when the stack is empty. So what will be returned? There is no element to be deleted. So in that case, we return a very uncommon number. Let's say -99999. So it is very unlikely that the user will enter such a number into the stack. So if we receive this value, it will indicate that the pop operation could not be done because the stack was already empty. The stack must be empty. That's why we received this element. And if we receive any other element from the pop function, we will understand that, okay, the pop operation was successful. So that's why we'll now write else return s top minus minus. So here we are doing post decrement, because first of all the element that needs to be deleted is returned and then top decreases by 1. So that is the pop operation. Next, we will write the code for the peak operation. So again, if the stack is empty, there is no element that we can display as the topmost element. So we will write if top is -1, we will print stack is empty, else we can display the topmost element as S of top. So that's the peak function. And finally, the display function, where we will display all the elements currently stored in the stack. Here also we have to write the code for stack underflow. So if top is -1 means stack is empty. So again we print stack is empty, else we run a loop from 0 index to less than equal to top, and we print those elements as S of I plus a blank space. Once all the elements are printed, we give an empty println just to change the line. So the display function is also complete. Now only main function is left. In main function, we will create an object of the stack, but before that, we also need to know the size of the stack. So we create scanner object first. We ask for the stack size. So int size equals integer dot %, int dot next line. And we can create an object. So stack, let's say my stack equals new stack, and we pass the size. And now we run an infinite loop while true, and here we will display all the options or all the operations that can be performed on the stack. So the first operation is the push operation. The second operation is the pop operation. The third operation is the peak operation. The fourth operation is the display operation. And the last operation would be to exit. Means if the user wants to stop the program. And now we give a message to the user. After displaying the menu, we display a message, enter your choice. So we are taking the choice as an integer. So int choice integer dot %, int dot next line. and we put it in the switch case. So switch choice case 1. In case 1, we have to perform the push operation. So to push data into the stack, we need to input data from the user. So we write system.out.print data to be pushed. So I write int data equals integer.parseInt in dot next line. And through the object myStack, I perform the push operation by passing the data to the push function. And then I call the break keyword to exit from switch. Next is case 2. Case 2 is for the pop operation. So we have to write int deleted. The deleted value will be returned by the stack. So myStack dot pop function will return the value that was deleted. So we have to check if deleted is same as this value. Let's copy and place it here. If it's equal to this value, this indicates that deletion was not possible. Stack must be empty. So I can write stack is empty, else I can print deleted popped. And after that, I once again call the break keyword for case 2. Next is case 3. We just have to call the peek function. So we will write myStack dot peek and break keyword, and in case 4, myStack dot display all the elements and break. And we can add a default case. So other than these 4 cases, if any other value is entered, we will understand that the user wants to exit. So we can print a message, let's say bye, and we can call the return keyword to exit from main. So once main exits, the entire program stops. Now let's try to check the output of this program. Let's say the stack size is 5. So now it is displaying me all the options that can be performed on the stack. So let's try to pop when the stack is already empty. So you can see it's printing stack is empty. Now let's try to push an element. Let's insert 10. And let's check. So I can call the peek function. It will display the topmost element. So yes, topmost element is 10. And because I have run an infinite loop, again and again the menu will appear for the next task that you want to perform with the stack. So now let's insert another element. So again call the push function and let's insert 20. So when we try to display, so you can see 10 and 20 are displayed. 20 is the topmost element right now. And keep pushing the elements. So 1. So this time we are inserting 30. Then again 1. We are inserting 40. Again 1. We are inserting 50. Now let's check. So you can see all these 5 elements are being displayed, 10, 20, 30, 40 and 50 that we have just pushed into the stack. Now if we delete, 50 should be deleted first because 50 was the last item that was inserted into the stack. So if we call the pop function, you can see 50 popped. That means 50 got deleted first. So if I check display now, you can see only 4 elements are left. And you can insert anything now also. So let's say I want to insert 75 now. And again, if I check, so now 75 is the last element that was inserted. And if you still want to insert, let's say 80, it will display now that stack is full. So it will never lead to stack overflow because we have written our code like that. And we keep deleting now. Let's say 2. So 75 popped, 40 popped, 30 got deleted, 20 got deleted, 10 got deleted, and now once again the stack is empty. And once you are done, you can just press any other number, let's say 5, and the program stops. So that's how you can implement stack data structure through arrays. I hope you have understood the program and the concept of stack. That's all for today. See you in the next class very soon. Thank you for watching.